For those of you just joining us through the virtual platform, my name is Eva Parada, and I'll be your MC for this evening. We would like to thank all of our guests joining us in person and online for your support in making this event possible. We are thrilled to bring you 3 dynamic presentations by highly accomplished professionals or innovative projects happening right here in Nova Scotia. Our first presenter, Julie DiCicco, Pienge, is an environmental engineer with a Master's of Applied Science from Dalhousie University. Julie is experienced in water and wastewater systems design, climate change resilience and adaptation planning, Indigenous consultation, and asset management. Julie is an associate with Dillon Consulting Limited and is passionate about delivering projects that impact the lives of Indigenous people. Julie will discuss working closely with the Atlantic First Nations Water Authority to develop individual asset management plans for water and wastewater systems for participating First Nations communities in Atlantic Canada, in Nova Scotia, New Brunswick, and PEI. Please join me in welcoming Julie.
Thank you all. So there was a great land acknowledgement done at the beginning, but I'll say my own. I live, work, and enjoy the traditional and unceded territory of the Wolastoqey and Pescataway people in southern New Brunswick. And I'll also attempt to visually describe myself. I am 5'4". I am a white French-Italian woman with grayish brown hair. I am wearing a black turtleneck and high-waisted beige pants. Do I just click? Great, so lower this a little bit. Thank you to Engineers Nova Scotia for inviting me here today to discuss our project with the Atlantic First Nations Water Authority in developing asset management plans for water and wastewater systems in 17 First Nation communities. So first, I'll introduce myself a little bit. I graduated from a Bachelor of Environmental Engineering from Dalhousie University in 2013 and went on to pursue a Master's of Applied Sciences with the Civil Water Resource Group. After graduating from my master's, I began working with the Atlantic Policy Congress of First Nations Chief Secretariat and as a policy analyst in the Water and Waste or Housing and Infrastructure Department. One of the projects that I worked on while there was the Clean Water Initiative. And this was a large project, a culmination of so many individuals' efforts over many years to establish principles and processes and a framework that would eventually be used by the Atlantic First Nations Water Authority to create the Water Authority. So it was great that years later, working with Dillon, I was able to work alongside the Water Authority on one of their major milestone projects of developing asset management plans for the water and wastewater systems that they would eventually assume control of maintenance for the First Nation communities. So my next slide, I'll talk a little bit about the Water Authority and a bit about their mission and their mandate. They're also here today, so if any questions are directed at them, I would definitely invite you to talk to them or invite them up to answer those questions. Then I'll get into the project purpose, the goals and objectives, the timelines, the items achieved as part of this project, and some of the project challenges. And then I'll go over the project conclusions and what are the major benefits that were realized for these communities. So the Atlantic First Nations Water Authority, or the Water Authority, is a First Nations-owned nonprofit organization that is providing a framework approach for managing water and wastewater services in First Nation communities. It was developed with the purpose of increasing control in decision-making, improving water and wastewater infrastructure, increasing levels of service, and building capacity within communities. Their mission is to provide safe, clean drinking water and wastewater in all participating First Nation communities in Atlantic Canada, delivered by a regional water authority owned and operated by First Nations. I wanted to read that word for word to make sure to get it right. It is a great mission. It was also one of the unique things as part of this project was that we were able to work in an asset management project for basically a newly incorporated company, organization. Typically in asset management projects, you work with a municipality or a company that already has a lot of procedures and processes in place on how they manage their assets. So it was great that the Water Authority realized the importance of establishing a framework, establishing a system before going in and completing this large project and assuming control of these systems and managing the assets in a way that they were able to think about before actually implementing these procedures. So the purpose of the project was to, again, develop asset management plans for participating communities to support the full life cycle of physical assets that support the delivery of water and wastewater systems. In ISO 55000, which is the international standard for asset management, it defines asset management as the coordinated activity of an organization to realize value from assets. And this is not only value in terms of what service this asset provides, but value in terms of the tangible cost of the asset. And this was a major outcome and milestone for this project to realize those tangible costs of the assets to help increase financial sustainability and assist with long-term planning and move away from a reactionary maintenance and management standpoint to a proactive standpoint, understanding the cost of items, the cost of maintenance, and the cost of services. So the deliverables as part of this project were divided into two separate phases of work. So the first one was the asset management plan development, which included an asset management framework, a condition assessment and operational survey, risk and level of service review, creating 10-year capital plans and a capital prioritization process, and establishing an asset management roadmap. What you see on the slide here is the asset management framework that was created alongside our work with the Water Authority. And as you might be able to see it, it matches the Water Authority logo and colors quite closely. And it separated into 4 different pillars of what makes an asset management system. People in leadership, important to understand the roles and who will be managing those assets. Information, what type of information, the level of detail in that information. The life cycle process, which talks about risks and levels of service that the Water Authority want to maintain. And finally, the financial sustainability, which is a culmination of all of those aspects into development of capital plans, the organizational business plans, and ultimately funding for the management and upkeep of these systems. The second phase of work was the treatment facility assessments. And this is not something that's typically included in an asset management project, but for this project, we completed environmental risk assessments on wastewater effluent. So that's an assessment of the receiving environment from the wastewater treatment facilities to understand if treatment enhancements or treatment upgrades may be required to meet the needs of that receiving water body. And GUDI assessment, which are groundwater under direct influence of surface water, investigations of drinking water wells that are currently treated to groundwater standards that may be impacted by surface water, and that would have some pretty high or pretty critical implementation or pretty critical implications to upgrade that treatment standard to surface level instead of groundwater level. So here I have a timeline of events over the 11 months of this project. So first, the asset management framework was completed in April. I talked a little bit about that, and that really helped set the groundwork for the asset hierarchy and the inventory that we created as part of this project. As I mentioned with the Clean Water Initiative, there had been a lot of previous assessments conducted for a lot of these First Nation communities that were in many different formats and many different levels of detail. So establishing this hierarchy was a pretty crucial point to understand what level of detail the Water Authority would like to have this information, this condition information going forward for this project, as well as the ongoing implementation of their asset management system. In June and throughout all the way to October, we completed the condition assessments and operational surveys. So the condition assessments were visual inspections done on lift stations, wastewater treatment plants, any sort of complex assets that you can visually see. And the operational survey we conducted very closely with the Water Authority and individual water and wastewater operators in these communities to find, locate, and GPS tag individual valves, hydrants, and manholes. And with the water operators, we exercised those drinking water valves and opened those manholes to identify operational upgrades that may be associated with that. In August, we established the risk assessment procedures and established current and target levels of service. This was a big piece in identifying some of the capital upgrades required, because upgrading the level of service typically means upgrading either maintenance procedures or the actual treatment process that's in place. In September, now that we had, collected a lot of this information, we were able to create the first generation asset management plans. In October, we conducted the GIS mapping as part of this project. This was not originally part of the scope of work, but we knew we would be collecting GPS data of the valves, so to 50 millimeters accuracy. And through our operational survey and our condition assessment, we used Esri-based tools so that it was easy enough to connect the Esri-based data that was collected to the GPS data and corrected that to have a pretty good high accuracy in terms of the water and wastewater network. But there was still quite a bit of work, because having points on a map is not the same thing as having a water network or a wastewater network. So we looked through a lot of record drawings, and some of it were either in ISC's standboard, so Indigenous Services Canada is ISC, or they were in the head of a water or wastewater operator that had been there 30 years, that just knows where things are at. So very much these GIS maps are first generation maps, but they still provide a lot of value and a starting point to have the information in one location. In November, we completed the 10-year capital plans. These were completed for individual First Nation communities, as well as completing an aggregate plan. And this is where the Water Authority did a lot of the work in creating and reprioritizing based on a capital prioritization process that we completed together. And we did this in November because it was also an Indigenous Services Canada funding deadline for their federal funding budget. So it was quite a rush at this time, since we had really just finished collecting a lot of the information. In December, we hosted, alongside the Water Authority, an operator workshop where we presented a lot of the deliverables as part of this project, and really focused the workshop to the tools and the systems that they may be using on a day-to-day basis and going forward. And in January, we established the asset management roadmap. And this was essentially an implementation plan and a bit of a next steps going forward for the Water Authority to use their asset management system, and how to use all of this information and these tools that we created as part of this project. So some of the project challenges, as I mentioned, the body of knowledge for this background research and this report, because of the Clean Water Initiative and so many years of work that had gone into this concept before the Water Authority was eventually realized, it was hard to, there was a lot of data gaps, and even though there were a lot of previous assessments. So we wanted to maximize on those past studies that had been used to not, have that, to use that to the best of our ability, but also create something that is to the level of detail that the Water Authority want to have moving forward. Something else is we did work with 17 communities across 3 provinces, so New Brunswick, Nova Scotia, Prince Edward Island, that had a total of 14 health zones. So this was completed, of course, during a global pandemic. So in addition to having provincial requirements and restrictions in terms of travel, there were also zonal restrictions at one point while we were scheduling all of our condition and operational surveys. So that required a lot of communication with the Water Authority and individual water and wastewater operators to make sure to schedule these condition assessments and site visits to everyone's comfort levels. So in conclusion, this project helped me realize many benefits, and I wanted to name a few here. So the first was the consistent asset inventory with condition information. So this really provided as well a baseline for these communities. Some of the information, as I mentioned, were in a very dedicated water operator's head, his knowledge or their knowledge, and some of it was in Indigenous Services Canada's repertoire. So it was great to be able to provide a baseline this way. Another one was understanding the facility treatment performance through the environmental risk assessments and the GUDI assessments that we had, which the GUDI assessments are still ongoing because of the sensitive nature of this. Third one would be the GIS map. So as I mentioned, it provides a first generation map of something that the Water Authority and the individual communities can build upon as new information is discovered. And finally, the prioritized list of capital projects that were completed as part of our 10-year capital plans. over 1,000 projects were discovered or were created over the 17 communities, which really, and these are not just small capital projects, they are large capital projects that will definitely have an impact on the water and wastewater service delivery. So that's all I have. I don't know if I have time for questions. I can't see the screen, but.
Into these kinds of communities, how do you ensure that you're listening and not imposing your solutions onto communities?
It is very much about listening, and great question, by the way. It's about understanding, listening first, and understanding their, for water operators that have been doing this for a number of years, they obviously know their ways, and we just want to be a help more than someone that comes in and says this is the right way. There's no right way. There's just ways to help and improve and make things more efficient.
Thanks. So we built this tool, great tool from what I can tell. Eventually we're going to hand this tool over. Who's going to manage this after? Because it's not going to stay in stasis. It's going to evolve and grow. Are you going to take that on, or is that going to be handed over to the Water Authority?
So we are very much continuing to have these conversations, and we are actually having a meeting tomorrow on continued workflow for the asset analysis tools that were created. And there were a lot of tools created as part of this. And it's not just, the roadmap provides a good plan of steps and items to achieve, but it doesn't give you the instruction booklet. So that is definitely something that we are continuing to work with. But the Water Authority, when we first started this project, I believe you had 5 staff, and now you're at 21. So they are very much growing, and the capacity in the organization is great. Yes.
Any others? Yep, one here.
Hi, Julie, this was an amazing presentation.
Thank you.
From a shipbuilder standpoint, with multiple shipyards, when you have things happening in different places, so much difference. Did you see many repeatable subjects that were consistently happening through habit or through creation that can be used as identifiers for future multiple works?
In terms of our work procedures? Or?
No, actually just start listening to their procedures and how the similarities may come out that will give tools for the future to maybe give it feedback, but not advisory, but more sort of some ideas in that way.
Right. So, I mean, I can speak to that through other experiences that I've had working with First Nations communities. Yep. There is a lot of similarities, but there's also a good culture of knowledge sharing that happens, and leaning on each other to be able to, understand issues and go through issues or procedures in place together.
Tremendous presentation. Great system.
Thank you.
Thank you.
Good.
Well, we're going to introduce our next presenter, Dr. Noreen Kamal, Pienge, is an assistant professor in the Department of Industrial Engineering at Dalhousie University. She received a bachelor degree in chemical engineering from the University of Calgary in 1993 and a master's degree from the University of British Columbia in 1996. A PhD from the University of British Columbia, after a PhD from the University of British Columbia in 2013 after working in industry for over a decade. Her work and research centers on improving health systems with a focus on stroke. Dr. Kamal is leading the ACT East Atlantic Canada Together Enhancing Acute Stroke Treatment project. The ACT East project aims to improve access to treatment for stroke patients and improve the timelines of treatment across all 4 Atlantic provinces. Amazing. Please join me in welcoming Dr. Kamal.
Thank you so much for that kind introduction, and it's an honor to be here with such esteemed co-presenters. It's lovely to be here with you. My pronouns are she and her, and I'm going to attempt to describe myself. I am similar to Pal, a South Asian woman with middle-aged, very, very short hair that's gray in the front, or white, I should say. And I'm wearing a white and black blazer with black pants. I hope that was good enough. Great. All right, so yes, I am here as representing the project that I'm leading called ACT East, and it's around improving stroke care through ACT East, Atlantic Canada Together, enhancing acute stroke treatment. And I'm here to also as an industrial engineer, that's the department that I work in. I'm not sure if there are any industrial engineers here. Woohoo! Yes! So I'll do a little bit of a promo for us industrial engineers, because engineers make things, industrial engineers make things better. Okay? And I don't mean that in a competitive way, only to say that we improve things, right? We make things better. All right, so as an outline for my presentation, I'll begin with some background and context. Then I'll talk about what ACT East builds on. So I'll talk about the previous work that I did that it builds on. And then we'll get into ACT East, the objective, methods, and benefits. All right, the background and context. So we've all know about stroke. We've heard about it, and we know that it has a very significant impact on society. So here are some of the statistics. It's actually the leading cause of adult disability, and it's often said that that's a fate worse than death. It's the 3rd leading cause of death, but it's actually going down. I think currently in Canada is the 4th leading cause of death, and that's because of some of the treatments that I will talk about shortly. Has an incredibly high cost to society, to the patients that suffer from stroke and to their family as well, and to the healthcare system because of the disability that it causes. And the final statistic that we don't often hear about is that stroke is actually the 2nd leading cause of dementia. It's called vascular dementia. Okay. So in stroke, the biggest factor is time. Time is brain. From the moment that the stroke starts, the brain starts to die very, very quickly. In fact, it's been quantified. There's 1.9 million neurons that's lost every single minute in an average stroke. That translates to 14 billion synapses in the brain, 12 kilometers of myelinated fiber every single minute. So there's 2 types of stroke. The most common type of stroke is called an ischemic stroke. That's when a clot travels up through an artery and enters into the brain and occludes blood flow into the brain. This is around 75% of all strokes are of the ischemic type. The other type of stroke is called hemorrhagic stroke. That's when a blood vessel bursts in the brain and you start to bleed inside the brain. The good news is that ischemic stroke is treatable. But there's 2 main types of treatment. The first type of treatment is a medical treatment called Alteplase, or also TPA, which stands for tissue plasminogen activator. And it was proven in the mid-1990s. It's been around for quite some time, and it's fairly effective. It's effective around 10 to 60% of the time. It's fairly widely available at all primary stroke centers. So to give you an idea, there are 10 hospitals across Nova Scotia that are designated as primary stroke centers. So it's pretty widely spread out and good access for our population. The second type of treatment is called endovascular treatment, and it's really new. It was just proven in 2015. And one of the key trials that proved it was actually a Canadian-led trial. I was very fortunate to be part of that trial. And this is a mechanical removal of the clot. If you can imagine, it's a minimally invasive surgery where the artery is punctured in the groin. A catheter goes through the artery of the whole body, through the heart, and a stent snares the clot inside the brain and it gets pulled out. It's highly, highly effective, but it's only available at large teaching hospitals. So in Nova Scotia, it's only available at the Halifax Infirmary. And it's given to people with very severe strokes because that clot has to be in a large vessel that's proximal. So it has to be accessible from the stent retriever. Both of these treatments are highly time dependent in order to be effective. So there's currently an evidence to practice gap. Both of these treatments are part of guideline care in Canada and around the world. However, utilization rates of both of these treatments are low, especially for patients that live in rural areas. And this has a much larger effect in Atlantic Canada. We in Atlantic Canada live much more rurally than in other parts of Canada. So across all 4 provinces, between 41 to 53% of our population lives outside of the cities. So if we compare this to BC and Ontario, it's only 14%. On top of this, that rural patients have less access to these treatments, we also have a greater incidence of stroke than other parts of Canada. So even not considering age, we standardize for age using statistical methods. Around 140 strokes per 100,000 people occur in Atlantic Canada. If we compare this to Ontario, it's 113 per year out of 100,000 people. On top of this, it's compounded because we have an older population. We tend to have a sicker population in terms of our chronic diseases. And then we have these little tiny provinces with small populations, which becomes much more difficult to deliver health services because health is delivered on a provincial level. So how are we going to make these changes? I'm going to build on previous work. So I come here from Alberta, and I led a big initiative in Alberta to make these improvements. So here's a visual abstract of the work that I led in Alberta. It was published in the Stroke Journal. And the actual intervention was called an improvement collaborative. So we analyzed the data before we did the 1-year intervention, and we compared it to after that 1-year intervention. So the door to needle time, that's the time from arrival at hospital to start of Alteplase treatment, dropped from 70 minutes to 39 minutes. So we almost cut it in half. What does this mean for the outcomes of stroke patients? We increased the proportion of patients that were able to be discharged home rather than going to long-term care or going to a rehab facility from 45.6% to 59.5%. So here's some images of the learning sessions. These were 1-day workshops. They were held throughout the 1-year period, and there were 3 of them held. And within this, what happened was all of the stroke hospitals assembled improvement teams and then we got together and we shared our learnings. We shared how to make improvements, but we also had a lot of cross learning between sites. So sites presented on what they were doing and they were able to learn from each other. So there's this peer-to-peer learning aspect there. Here are the results. These are door to needle times. The shaded green area shows the time during the intervention itself, and the median door to needle times are shown on a quarterly basis across the whole province. So you can see how substantially the times dropped after the intervention. Here is a comparison of the outcomes. I've already talked about the proportion of patients that were discharged home, but we also saw a reduction in mortality from 14.5% to 10.5%. And in terms of 90-day home time, this is really a surrogate for disability. This is in the first 90 days after the stroke, how many days were patients able to spend at home rather than in hospital, in long-term care, or in a rehab facility. So that increase from a median of 39 days to 71 days, really showing a huge effect of the intervention. So let's get into ACT East, which is why we're here to talk about it. We're still in the process of it, so I don't have the effect of the intervention, but we'll talk about what we're doing. In terms of funding, I received a very nice grant from CIHR, very honored to have received it. It's a highly competitive grant to get. Around 15% of all profs that apply for it actually get it. So I got that. Most of the funding, $317,000. I also got $25,000 from Alberta. Got to use their money around here as much as possible. I got $6,000 from industry. Hopefully we can increase industry funding for this type of stuff. And Nova Scotia Health also contributed for travel for their employees. So what are the objectives for ACT East? The main objective is to increase the proportion of ischemic stroke patients that receive either treatment by 5%. We want to reduce the time to treatment, so time from arrival to start of Alteplase treatment to a median of 30 minutes. We want to reduce the time to endovascular treatment from arrival to groin puncture, that start of the endovascular procedure, to a median of 60 minutes. And for all those patients that need to get transferred from the primary stroke centers to the comprehensive stroke center where the EVT is offered, we want to improve efficiency of transfer. So that's door in, door out time. Arrival at hospital to when they're leaving that hospital to a median of 50 minutes. So here's the actual intervention. It's a modified improvement collaborative. This particular intervention comes from the Institute for Healthcare Improvement, IHI, out of Boston. So similar to that image that I showed you in Alberta, all of the stroke hospitals enroll an improvement team. That's an interdisciplinary team made up of paramedics, nurses, physicians, CT technologists, radiologists, and they are all the people that are involved in treating that patient. They come together for that first learning session, a one-day workshop. Then they, during that workshop, they also start to plan what they're going to do, and they let everyone know about their plans. They then go into that first action period when they're actually carrying out that plan. There's a couple of months later, we do another one-day workshop, and this one there's more peer-to-peer learning. They talk about what they're doing so that they can learn from each other. And then the final second action period. This is supported through site visits, webinars, data collection, and data feedback. And this entire thing takes 6 months. There's dates here, which I'll get to in a second in 2 slides, but let's just talk about, well, what are these changes that people are actually going to do? They do get a full change package, which goes into the changes in a lot more detail. But if we go through this process diagram, all of the actual improvements are highlighted in yellow. It starts with the stroke. The ambulance comes, picks up the patient, and then they pre-notify and pre-identify the patient on the way to the hospital. The stroke team then can prepare for the hospital, pre-register the patient, look up their medical history. When they arrive at the hospital, there's a quick assessment. They keep the patient on that EMS stretcher, take them directly to the CT scanner, which then actually confirms that it's an ischemic stroke. Even before that, you can clinically confirm that it's a stroke and start planning for that transfer ahead while that patient is in the CT scanner. And then if the image shows the right stuff, they can actually start that Alteplase treatment right in the imaging area and then transfer the patient immediately for endovascular treatment. So how are we actually carrying out this work? We're using what's called a stepped wedge design. In medicine, in order to actually validate a new medicine or a new treatment or a COVID vaccine, what's used is a randomized control trial. So patients are randomized either to receive a treatment or receive a placebo. Of course, we're making changes on a hospital level, so we can't just randomize a patient. So what's often used in these cases is what's called a cluster randomized control trial, and you randomize the hospital to either receive the intervention or not receive it. But that's often thought of as being unethical. How is it that one hospital receives all this benefit and another hospital doesn't? So the way that we've overcome this is to design what's called a stepped wedge trial. And essentially the intervention happens in a phased approach for different groups. We're using a pragmatic trial. Ideally, we would have randomized each site to different steps in the stepped wedge, but we wanted to keep all the people within a province and a health authority together. So Nova Scotia went first with that 6-month intervention, and that started back in November 2020. There were 10 hospitals across Nova Scotia that are stroke hospitals that participated. We then went directly into the second cluster, which was New Brunswick and Prince Edward Island. There were 13 hospitals there. Thank you so much. Must sound bad. Thank you. Okay. And then finally, we're in the third cluster, which is Newfoundland Labrador, and that's expected to finish in April. So we collect data 6 months before that first cluster started, and we collect all the data across all the hospitals to 6 months after, and we compare the green areas to the orange areas to see what kind of effect that our intervention had on the outcomes and the objectives that I outlined previously. So what is the expected outcome or the cost and the cost benefit of this work? It is estimated that an additional 7 to 15% of ischemic stroke patients will be functionally independent. So this translates to between 260 to 550 more patients every year that will be able to return home after their stroke. What does this translate to in cost avoidance to the health system? $7.8 million every year. So if we reflect back on the amount of investment that was made by CIHR and the other places, it's a huge rate of return. And this is not a new therapy. This is not a new intervention. This is not a new innovation. We're just doing things better. That's everything. I know I went on, so I don't know if there's time, but I'm happy to take questions.
An engineer since 1981, graduated from Tons. I'm celebrated my 18th year, 2 months after near-death clinical stroke, 2 minutes and 2 seconds gone. I lost, my eye popped out and my head was saved. And I just want to thank you. And I want to advise every single person in this room, whatever you do, however big a project is, never, ever lose sleep and work overtime. Do never do that. I did. My family nearly lost me. I want to thank you.
Thank you.
Pat Sweet here. I wanted to ask a little bit about the differences that you've seen from hospital to hospital. I imagine that's a major challenge while trying to roll out a common intervention across the board, and what you've done to address those challenges and then sustain the intervention over time as well.
Yeah, that's such a great question. In healthcare, they often say, when you've been to one hospital, you've been to one hospital. So everyone thinks they're unique, right? And I think that that's one of the key challenges when you're trying to roll out anything across multiple hospitals, which is really why this IHI intervention, I believe, works really well, because you make suggestions, but you allow the teams to trial the changes for their own context. And then, and what often happens in other types of intervention, you have the teaching hospital saying, thou shalt do this, or the health authority coming down on people saying, you know, this is the new protocol, you guys should do this. Whereas this is really a grassroots type thing, and it allows, rather than me telling you what will work, why don't we hear from Turo talking about how they implemented their changes, because it might help St. Martha's, right? Like that's, it's really, I think that is the most critical aspect of the intervention that I think works the best. So yeah.
Thanks, Dr. Noreen. That was a great talk. So industrial, I don't want to get into which is better, industrial or any other discipline, because there's lots of opinions out there. But in the sense, as an industrial engineer, going into an environment where you're coming up against other subject matter experts
Yeah.
who have developed a system that they believe is working.
Yeah.
How do you establish credibility, and how do you establish a rapport
Yeah.
that makes people accepting of the changes you're proposing?
Yeah, that's such a good question. And I must say it was much harder out west because there's no industrial engineering program, and engineers don't have as big a role in healthcare as they do in Atlantic Canada. So I really want to compliment the system out here for hiring so many industrial engineers to make the healthcare system better. For me, and one of the reasons I've stuck to stroke, because everyone's like, okay, what's your next disease? And you know, it's, you know, I did my postdoc with leading stroke neurologists in the world, and that was my main reason to go to Calgary. And I, you know, sitting in stroke rounds, learning about the disease, and really being able to understand the nuances of the disease helps you to build that credibility, rather than coming in here saying, I'm just going to make a process map and tell you how to do this better without really understanding the disease will not work. Yeah. Wonderful. Well, thank you so much for being such a great audience.
Well, that was pretty incredible just to learn about how engineers are changing the world in the healthcare arena, and how many people's lives are changed because of the work of engineers. Pretty amazing. Finally, dessert started. Okay, good. Our final presenter, Natalie Leonard, Pienge, is a civil engineer with a Bachelor of Engineering from Tons, and is the first certified passive house consultant and certified passive house builder in Canada. Her mission is to make sustainable high-performance homes affordable for everyone. She leads the passive design solutions team with a depth of experience in creating cost-effective, beautiful, and ultra-efficient homes. Natalie brings her engineering background, hands-on design, and construction experience, and a practical approach to building. Natalie will discuss the Net Zero Passive House Sunflower Social Housing Project in Halifax, Nova Scotia. This project is a housing complex for the undeserved populations of women and children. Wow. Please join me in welcoming Natalie.
Thank you. It's a couple of hard acts to follow here. So thanks for staying awake for the last presenter. And I will start by describing myself as best I can. I'm a 59-year-old white woman with brown hair, mostly brown, starting to get some gray as well. And I wear glasses to drive, but not here. And I'm wearing a bright orange shirt. So I'm good and visible. So thank you everybody for your attention. Let's see if we can get this thing moving here. So how many people here have heard of Passive House before? Wow, okay, awesome. How many have heard of Net Zero? Okay, a little bit more for Net Zero than Passive House looks like. So yeah, so just to give you a little quick background, Passive House is a German high performance building standard that has come to North America in the last 15 years. And what we're really trying to do is use the Passive House principles to optimize the efficiency of the building such that we're at the point where putting renewable technologies into the project makes the most financial sense. So, and this approach to projects is really important to affordable housing, because they can write all those grants and find that money to build projects, but then they have to operate them. So by making a building net zero, making a project net zero, it drastically reduces the energy cost for building. So for example, there's a new affordable housing project, the Travel Lodge has been on the news. Many people have probably heard about it, where they're converting an old hotel into into emergency shelters essentially. And I just in working with the project team, their energy costs every year are around $65,000. So that's a lot of money for a small not-for-profit. So ADSM is the first affordable housing project that our team has had the honor to work on, and it really is an honor. We take a lot of enjoyment and benefit to ourselves by doing work that we think contributes to the planet through energy efficiency. But when you overlay designing and creating housing for the underserved populations, it feels a whole lot better. So it's a big project team. I won't read everybody off here, but it's a fairly substantial group, and everybody's really committed to the mission of the project. Kind of feels like 8 people in a boat rowing in the same direction as quickly as we can. So ADSM for women and children is really an incredible, they're a tiny organization with very few employees. They shelter as many as 120 people a day and over 300 people a year. And they've learned that they really need to provide support to these people. Just providing housing is not enough. They need quite a bit of support and ongoing services to go with the stable housing and food, clothing, and connection. They do cooking classes and counseling and a number of other support services. Our company is a design firm here in Halifax. We work on custom architectural design. We've also developed a series of passive house stock plans to make it more accessible to the mainstream. And we've worked on more than about 250 passive house projects. And passive house is still pretty new. So we're really trying to ramp up, because if we're going to make a difference to the planet, we need to have a lot more energy efficient buildings. As I say, building six or so custom houses for the rich and famous is not going to solve the climate challenges. This project had some lofty goals. They wanted 25 residential units. 4 of those had to be fully accessible. They were currently in an old school that was donated to them by the city. Very dark, chopped up spaces. So we wanted the spaces to be warm and inviting, to use affordable construction. They needed a community center along with the residential units, and they wanted to use the passive house approach to get them to a full net zero project using PV solar system. And then things like durability of the exterior finishes and interior finishes. Again, really keeping an eye on the maintenance costs that are impacting this NGO in managing these projects going forward. Safety was also a big consideration for the project. Most of these women come from situations of domestic violence, so that there's no entrances on the backs of the buildings out into the backyards. All the entrances face a courtyard, and the community really watches out for each other by having that inward focus. As I mentioned, the land was donated by HRM, and the project was successful in an application for rapid housing initiative. So they got $4 million in funding. It's one of the first times we've seen fully funded projects for affordable housing from the federal government. It required panelization or modular construction, and it also required completion by March 31st. Well, it's about 3 weeks. You'll see the pictures. It's not going to happen. There's also a lot of private donations and other government funding from the province. And I think they have about a $90,000 rebate from Efficiency Nova Scotia for achieving the level of performance that the buildings will have. It has been really challenged by COVID cost increases to construction. This room will be very familiar with the challenges we've seen there. But they have managed to cobble together the budget to keep the project going. We wanted to use the already cleared cleared pad that was cleared for the school to reduce the impact by cutting more trees down. You know, overall, we're trying to make a contribution to the fight of climate change. So we don't want to start by cutting down a whole bunch of trees that are helping in that. We did a lot of work to design around the existing grades so that we could save construction costs on cut and fill and blasting. We used the existing driveway and we oriented the buildings as best we could to south so we can get free heat from the sun as well as daylighting, and reduces the amount of lighting energy that's used. And again, I already mentioned the orientation around the playground, and we kept the parking in behind the buildings. So this will be a little bit difficult to see, but the community center is the building on the far left. And we divided the buildings, we divided the units into 4 separate buildings, which allowed us to keep them as Part 9 construction and avoid the incremental costs of Part 3 commercial construction, of sprinklering and other requirements of the building code. So each building is under the 600 square meters to allow them to qualify as Part 9 buildings. We use simple building shapes in passive houses because they're more energy efficient, but they're also cheaper to build. So then we have that challenge of trying to not make them look like the Soviet block housing, make them interesting. And Molly Merriman is the architect on the project, and she's my guest here tonight. So that was her job in the project. We used a simple gable roof, much less expensive to build than other. Lots of people think a shed roof should be the simplest, this less expensive roof shape to build, but the gable roof is actually the cheapest to build, and we wanted a north-south orientation on that roof so that we could add the solar panels we needed to get to net zero. So I always tell people about 50% of a passive house efficiency is achieved during design, and about 50% is achieved by what you put in the building. So you want to utilize your design as much as possible because it is the most cost-effective way to get to net zero. So simple things we did, like eliminating structural bearing in the demising walls by running the trusses back and forth on the building. We stuck to 2 stories for the buildings, which eliminated extra egress stairs to a 3rd floor. We minimized the exterior maintenance by designing for interior stairs only. It's a real challenge. All these fire escapes and exterior stairs are really difficult for them to keep maintained. We used small windows that operate, just because big, heavy triple windows tend to need more service. And we have a single entry, as I mentioned, from the courtyard. So then it's affordable housing. We have a fixed budget. We need to make it cheap. So what are the strategies we can implement from a design perspective to impact the construction costs? So we had a great structural engineer on the project, Andrea Doncaster, who's a Dell graduate and then taught at Dell. Many of you may know her. She really worked with us to minimize the structural elements as much as possible. So a simple thing like engineering a 6-inch frost wall instead of an 8-inch frost wall reduced our concrete by 25% on the project. And concrete, steel, and glass are the building element materials that have the most embodied energy in them. So if we're trying to get low carbon buildings, we want to reduce our use of concrete. And also we managed to do our bearing of our floor systems without interior bearing walls, which reduced concrete and thermal bridging for us. We used the structural engineer to design the roof trusses, because one of the things that happens if you send them out to the roof manufacturers, they greatly over design them, using more materials and adding cost. Most of the buildings have that front to back gable. We did, for architectural interest, have a front gable on some of the buildings, and they're just basically false gables sitting on the simple front to back gable. Just keeping it really simple to build and giving us enough area for the solar panels to face south. The roof was built on the ground and then craned into position. to save staging and all the labor that goes into the up and down of building the roof on the second story. So what kind of assemblies do we need in this kind of building to make it a passive house and achieve net zero? One of the cheapest things we can do is add blown-in cellulose in the attic. It's cheap, it's locally made, it's 98% recycled. And so we just use standard roof trusses with a whole schwack of blown-in cellulose in the attic. The wall is the tricky part because there's a lot of elements that have to interface with the wall, your windows, your doors, making sure we don't have thermal bridges at the connections to foundation and to ceiling. So we used a double stud wall that was made in shop. The framing was made in a shop and then craned into position. So part of the meeting the panelization requirements. And the foundation, we just used a cast in place frost wall. We sometimes use ICF, but this builder was more comfortable with cast in place concrete. And we've got 2 layers of insulation under the slab instead of a code built would be 3. The walls basically are about 33% thicker than code, and the attic is almost double code. So by wrapping the building in a big thick parka, we're reducing those transmission losses. So larger buildings are more energy efficient because their volume to surface area ratio is better. So we can thin those walls down. Sometimes we need our 50 to achieve the efficiency in smaller buildings. And what we're really trying to do is use the energy modeling tool during the design to optimize, is it cheaper to put solar panels on the roof, or is it cheaper to add another inch of insulation in the attic? And by doing sensitivity testing with the energy model, we can determine that as we go through the design. Air tightness is a huge part of a passive house. A typical passive house is about 6 times tighter than a standard code built house. And the research shows that about 40 to 50% of all heat loss is through air leakage. And it also leads to huge building durability issues. Moisture is carried into the wall by air. And when you build really thick assemblies, moisture can go in quickly with the air, but it only can diffuse back out. So leading to rot, mold, and building failure. So air tightness gives us that energy efficiency, but also building durability. And we use as many locally available products and materials that are available at local building supply store to keep things familiar for the trades, which controls the labor costs. Coltech was a window supplier, and they also made a generous donation to the project to help with the cost, and they're locally made in Divert product. The heating system was probably the most interesting design discussion. A lot of the discussions were with the owner. So yes, we want the most efficient energy heating and cooling system, but in this kind of project, we need to consider the end users and the operator. So we looked at having a ducted heat pump system where with some central controls, but it was too expensive. We looked at using electric baseboards in conjunction with a single ductless mini split, but there was a feeling that the tenants would use the electric heaters because they're simpler to operate. So the effectiveness of the heat pump would be lost. That people will leave the windows open and run the cooling, and there's really no way to control that from a user perspective. And then there's a really high turnover in their occupancy. So ongoing training of how to use the system. You know, a lot of these tenants are coming from living off the street. So give them on a complicated remote control for a ductless mini split is not a good option to keep their life simple. So in the end, we decided to put in electric baseboards. You turn a knob, the heat comes on, you turn the knob, the heat goes off, and very simple to maintain and inexpensive to install. We'll make that up with solar panels to provide the extra energy that's needed without using the heat pumps. So what were, so I was thinking about some of the key aspects that got this project ready to build in short order. And we had a highly collaborative team. We had sub-consultants that were really willing to work with us around the kind of strategies we wanted to implement from an energy efficiency perspective. As I mentioned, the energy modeling shouldn't be done at the end. It should be done during design, so you can use that input to affect your design decisions. And again, I'll emphasize that using locally available materials put together in a different way to achieve a high performance building is get you over that hurdle of change with the labor, but also is very cost effective and provides you local service. Now the construction update. So the first problem they had on site was they discovered an oil spill from the old school. So they had to stop and deal with that. And then the next thing they experienced was bedrock. Even though we dug a number of, drilled a number of geotechnical tests before design, bedrock's all over the place. And so we had to do a lot of re-engineering to work around the bedrock. And that brought us into winter construction. So they were installing windows in the first building this week. So I don't think anybody will be moving in for March 31st, but I understand that the money is already at the city and the project will be completed as soon as possible. So that's it. I'm happy to take questions.
Looking at this house, there's a fair amount of engineering compared to a traditional house we bought off the shelf. In terms of the cost,
yeah. So on this type of multifamily building, that engineering would be required regardless of if it was a passive house or a non-passive house. There was some special engineering that needed to be done around the fastening schedule between the two panels. But other than that, all the other aspects of the engineering, I guess engineering the trusses for solar as well. But mechanical and electrical engineering must be done. There was some but I would say, way less than 1% of the soft costs were related to services directly related to upgrading to passive house. And before COVID in Nova Scotia, we could actually build a passive house for the same cost as the code built house because we could get a $10,000 rebate from Efficiency Nova Scotia and eliminate the central heating system. And those two things would add up to the incremental cost of upgrading to passive house. And I don't know where costs are these days. It's so hard to keep track of them. I can't claim that anymore. But normally we tell people about a 5% upgrade in the construction budget to upgrade to passive house. Right here.
Yeah, I'm Carl Yates. I'm with the Lang First Nations Water Authority, and obviously like to talk about, about water. Now, recognizing it's still the best deal in town, how do you still manage to incorporate any efficiency aspects into the house as well and describe those?
Yeah. Thanks for that. It's a great question I didn't touch on. So after you take care of heat and cooling in a passive house, and a 2,000 square foot passive house, you could heat on the coldest night of the year with the equivalent of 2 hair dryers. So that's the level of efficiency we're going to with the building envelope. Then hot water becomes your next biggest energy user in the building. So we do a lot around centralizing the plumbing layout design, insulating both the cold and the hot water lines, and using low flow fixtures, and then using a hot water heat pump, which doesn't affect the water use, but does impact the amount of energy that's used for water. Unfortunately, wastewater, it doesn't enter into the passive house aspect, but the I mean the sewage discharge, we don't do any calculations on that, but the supply of water is a big aspect in the design, reducing that water use. Thanks, everybody.
Thank you, Natalie. That was very interesting presentation on passive housing. How is that making a difference again in underrepresented communities? Thank you to all of our presenters tonight. As a token of gratitude, Engineers Nova Scotia is offering a 1,000 entrance scholarship through tech exploration. This scholarship is available to a student who is a woman, who is pursuing a degree in engineering and have demonstrated a commitment to creating a better world through supporting their local or global community. Engineers Nova Scotia has long been a proud sponsor of Tech Exploration, which is a non-for-profit organization whose goal is to increase the number of women working in science, engineering, trades, and technology-related occupations by assisting young women from diverse backgrounds to explore a wide range of career options in fields where women are significantly underrepresented. We'd like to thank our founding sponsors at Meridian Recruitment Solutions, as well as our table sponsors for their support in making tonight's event happen. Thank you to the Westin and to all of those who prepared and served the wonderful meal this evening.